So, let's see. Today we are going to be doing a lot of reading, a lot like what we did for our bear block today. We are going to be doing that. I had you guys do a reading for your do now, and then I had you guys answer the questions in your notebook. But it seems like you guys really enjoyed highlighting the questions and the answers. So if you guys would like to do that, is that something you... All right. And so, we don't quite have time to read the passage out loud. We do have to kind of move on. But let's answer the first question. What does the Richter scale measure? I'll read.
The Richter scale measures. Oh.
Say it out loud as well.
The Richter scale measures the strength or magnitude of an earthquake.
Alright. Oh, let me get the highlighter for you, sorry. Good job. Alright, so the second question, what magnitude was Japan's 2011 earthquake? Anaya. Yeah, and say it out loud. What's it out loud? Did y'all hear?
No.
Oh.
My bad. I said 9.0.
What was the 9.0?
The magnitude of the.
What earthquake? The magnitude of Japan's 2011 earthquake was a 9.0. You saw I did that?
Yeah, guys. Yeah, that's what. Yeah.
Third question, why was Japan's 2011 earthquake so destructive to Zaria?
It was so the Japan's 2011 earthquake was so destructive because of the violent shaking, and it was also triggered. It also triggered a massive tsunami that flooded towns and destroyed homes.
Great job! According to the passage, what can a magnitude of 6 or 7 earthquake do? Valerie. You guys are doing so good. And you guys see how, wait, say it out loud, sorry.
Such as magnitude 6 or 7 can damage buildings and crack roads.
Alright, great job. Alright. You guys did a really great job. Do you guys remember the first time we annotated a paragraph and y'all highlighted the whole entire paragraph?
Yeah.
Okay, look at this. You highlighted only the important stuff. You guys are getting a lot better at annotating. And we're going to practice that a lot more today. While we are practicing that, while we just did a review over earthquakes, we are going to, where is my clicker? There it is. Oh, let me remind you guys, the Science Fair project is due when? Tomorrow. Okay, if you haven't started
I got a
it,
question.
I would start it today because it's due tomorrow.
What is the background researching?
So like, your sources and stuff.
Oh, okay.
Yeah. Science fair, at least have the board. You don't have to have the prototype unless you are selected to go to the science fair on at school. Yes.
What is the future direction? Look at that.
Future?
Yeah, it said future direction on it.
Oh, you're right here.
It said future direction. Look at that.
Go right like over here.
It's like the directions to make it.
I already did that though. I need to.
How does this help you in the future? Why was this so useful to do this experiment? How will it help us in the future? Standards are text questions to compare and contrast the Earth's crust, mantle, inner and outer core, including temperature, density, thickness, and composition. And then the learning target is I can investigate volcanic eruptions. So I want to show you guys a video of the handy dandy volcanic eruption because I was supposed to do it, but I don't have a volcano. That's your project?
That's my project.
No,
Oh, is it?
something
Yeah.
else.
Alright, so how to make a volcano with baking soda and vinegar. So I want to show you guys this video.
What would do that?
You guys gonna fill out a sheet. Let me get the sheet passed out to you guys.
Can I pass it
Of course.
Pass it with this one.
Hmm?
Pass it with
Yeah, they're still part of the class. I'll give it to them. What are you looking like that for? Maybe just have a little mug on their faces. Was that not nice? Was that not nice? Alright. Everybody got a piece of paper? No?
Now, the chemical reaction we're looking at today is the old vinegar and baking soda volcano. But this reaction doesn't have anything to do with volcanoes. It's chemistry. Now, this experiment is totally safe, but I do recommend you get an adult permission before you do it because it's very messy. First, you're gonna want baking soda and vinegar. These are your two main ingredients. But you'll also want dish soap and red food coloring if you want it to look a little bit more like lava. Now, I like to mix the baking soda, red food coloring, and dish soap together with a little warm water, so all you have to do is add the vinegar. And when you do, this is what happens. And there you go. Chemical reaction. Now I know what you're thinking. You're thinking, Phil, how much vinegar or baking soda do I use? Well, I'm not going to tell you. This is where you can do science maximized. Try different amounts. More vinegar, more baking soda, more dish soap. Who knows? Write down the amounts each time you use it and find out what amounts work best. That's called science.
He looks fun. Alright, so now what you guys are going to do is you're going to reflect off of that lab. But let's take a look at the first question together. So you guys understand what you're answering. The first question is asking, observe the demonstration. You guys are going to draw, I want you guys to draw a sketch of what you guys just seen, okay? For the second question is what happened when the baking soda was added to the vinegar. You're gonna explain what happened. So how do you guys think, the question he asked at the end? He asked, well, no, don't interrupt me. He asked, pretty much like, well, he proposed that you guys proposed a question of what would happen if you added more baking soda than vinegar or vice versa. And so when it asked how would a different size be erupted, since we don't have different size, I want you guys to think about what you guys would think would happen if you added more baking soda or more vinegar. Does it make sense? Does it make sense?
Yes.
Okay. And then how do you think volcanoes change Earth's surface? How has it affected Earth as a whole? How has volcanoes affected Earth as a whole? Okay? That's more to get you start thinking more. We did not go over that in that video just now, but it's just to get you to start thinking more. Alright? So you're gonna draw what you've seen, explain what you've seen, and then try to apply that to the rest of the world. Alright? Yes. Yes. Can I have my pencil sharpener? Don't worry about that question. Just think about what you think would happen if you added more baking soda or more vinegar.
My name is Phil, and I take your everyday science experiments and do them big. This is Science Facts, experiments at Earth. You guys have 3 more minutes?
down to Chanel. This side, pass it down to Jordan. The next day, we'll pass it on to Elia. Okay. Next, what we're going to do is we're going to do reading and annotation, and then we'll do an exit TER. So I do have to move chronologically. We have 30 minutes to do the reading, annotation, and then to do the CPR. I see it. All right, you're receiving a reading from Kamaya and a highlighter from Aubrey. Have a good day. She does a lot every time she comes to my room. Ask if I have some students for writing, homecoming, and then if I had sex. All right. All right. I'm going to give you guys about 10 minutes to read and annotate. The questions that you are looking to answer are as follows. Read the passage, annotate to answer the questions below. Where are the central Andrews located and why is this region known for so many volcanoes? Give an example of a stratovolcano and what material is associated with these erosions. All right. It's only 3 questions because I'm trying to get through this, but I'm going to give y'all 10 minutes to read and use your highlighter or pencil to underline. All right, voices. Okay. Have a good day. 3 minutes and 30 seconds. Bring him over first. The last question, what material is associated with these erosions? It was supposed to be eruptions. Eruptions, not erosions. What's that top saying? Hi. Lord. Okay. Is what materials associated with these eruptions? These volcanic eruptions. Thank you for pointing that out, Sharon. You got 20 seconds. And then we'll go over the questions, and then we'll do our CER, okay? I know, we have a lot to do today. Alright, so the directions was to read this passage, annotate, answer the questions that are on the board, okay? So, first question is, where are the Central Andres located, and why is this region known for plenty volcanoes? Alright. Andrew.
The Central Andres
I don't know. You're scared.
are located between Chile and Argentina. They are known for having so many volcanoes due to the layers of earth sediment and
Very close. Now this is a two-part question, and I will admit the second part of this question is not in this text. I was just kind of hoping you guys will remember when we watched the video we watched before break. Remember the video about why is South America lopsided? Yes. It's because it's on a fault line. So the reason why there's so many volcanoes in that area. Oh, wiki. The reason why there's so many volcanoes in that region is because it's on the fault line. Make sense?
Yes.
Alright. Great job. Andrew showing us where you got your answers. Alright, second question. Give an example of a stratovolcano. Taylor.
Volcanoes are made by the buildup of lava flows.
Alright, and what's the name of one?
The name of is Cerro volcano.
Did you say it correctly?
Forgot what?
Well, I know there's other names.
Nevada, Ojos, Del Salado. Alright, great job, great job. Alright, then what material is associated with these volcanic eruptions? Victoria.
The one material that is associated with these eruptions is the welded stuff.
How is it formed?
By molten and fragmented rock that accumulates on the ground and later solidifies.
I'm so proud of you guys. Raise your hand if you read this and you were like, what am I reading? Because of all the big words. And that's okay. But do you guys see how you guys are still able to answer the questions because you comprehended what you read? You used context. You used your critical thinking skills. I'm very proud of you guys. You guys did a really great job with this assignment. Go ahead and keep this reading. Go tell your moms about the volcanoes that y'all learned about. And in the meantime, what I want y'all to do is create a CER template in your notebook. Whoa, the screaming is crazy. What causes a volcanic eruption? What causes a volcanic eruption? I got 15 minutes on the class. I gotta show y'all a quick video to help you with your evidence. So I'm gonna give y'all 2 minutes to make this template. It shouldn't be that hard. 2 minutes. To make a template. Oh, voices. Okay, I got 40 seconds left on creating CER template. Okay. I'm gonna walk around and pick up your highlighters here soon. Alright, we're gonna go ahead. You have 10 seconds left, and we're gonna go ahead and show you guys this video to help with your evidence.
The West Coast, South America's often solid as
The surface of the Earth, the crust, is comprised of a number of tectonic plates, which are constantly moving slowly at about the rate your fingernails grow. Most volcanic activity occurs at the places where these plates meet, the plate boundaries. The large layer of rock beneath the Earth's crust is called the mantle. This is mostly solid, but in certain places it can melt to become magma. This causes volcanic activity. At mid-ocean ridges, tectonic plates move apart. This creates space for the mantle rock below to rise. As it moves upwards, the pressure on the rock decreases, allowing it to melt. When the magma reaches the surface, the ocean water causes it to cool, creating giant pillow-like formations of a rock called basalt. These rocks make up most of the sea floor. At subduction plate boundaries, a thin oceanic plate slides under a thicker continental plate. The oceanic plate is saturated with water, which it drags down into the Earth. At around 60 miles deep, the water trapped inside is released, which reduces the melting point of the surrounding rock, allowing it to melt. This melted rock cools as it rises. Different minerals cool at different rates, and one of the last to cool is silica. The magma which eventually reaches the surface is silica-rich, which makes it thick and gloopy. Because the magma is so thick, the gases released on melting get trapped in large bubbles. When one of these reaches the surface, it bursts. This is what causes an explosive volcanic eruption. There are also a number of so-called volcanic hotspots away from plate boundaries. Here, mantle rock is melted by a plume of heat originating from deep in the Earth. The Hawaiian Islands were formed over one such hotspot and still contain the world's most active volcano, Kilauea.
Alright, so I want you guys working on your CER and answering the question, what causes a volcanic eruption, okay? Please make sure you're being smart with your time. I really have like 10 minutes to do this. Well, really 8. I want to give you 8 minutes. We're quiet.
change.
No.
No.
No, yeah,
It's
supposed to
supposed
change.
to change in January.
Okay.
I'm supposed to change this one.
No, some people still change this. Inside.
I'm still recording. We can't have y'all in here yet. I think this works. We're gonna do this tomorrow too.
Okay.
Exactly like that.
Mm.
You should go down and sign that paper. What you look at me for?
Huh?
Who you? I got like 2 minutes left. If you are done with your seat, or just start clearing off your table, but don't get out your seat. Yes. All right. Does anybody want to share after CER? Oh, I just have a phone call. Eeny, meeny, miny, mo. Who am I gonna call?
So what causes a volcano?
Voices.
Oh, something that is causes a volcanic eruption is when pressure like it I don't know how to say it. Like it like something rises like to the crust and mantle and like it erupts.
The magma? Good job.
Good job, Jordan.
You all agree?
Yeah.
Alright, let's look at the one I got. Volcanic eruptions are caused by pressure building up from hot melted rock, magma beneath Earth's surface. So your claim was the same, but y'all need to work on having your evidence and your justification or your reasoning. Evidence, magma rises from the mantle and traps gases. These gases expand and create strong pressure beneath the crust. Justification, when the pressure becomes too great, the magma pushes it through the cracks in the crust, causing a volcanic eruption, okay? That makes sense? I'm the only one talking. Does that make sense? Alright. You guys did great work today. I understand today we did a lot of work, we did a lot of reading, and you guys pushed through. What I need you guys to do now is let's please take a seat. Alright. You're going to, without getting out your seats, without talking, you're going to put everything into your backpack. It's your notebooks, your papers, pencils, except my pencils, Kamaya, Marcellus, Payton, Ariana, yes, Marcellus. Carriers of Marcellus, Marcellus, and Marmellus. Yes, please put your reading in your bag. I do not want it. Voices are off right now. You do not need to talk to get what you need done. We are cleaning up quietly. No talking. Carry on. Hello? Good night. Jackson, put it away. Everything's been good for. Grab your pencils. Your table should be clear. I don't know what that. I do not want that. All right. Now that your tables are clear, please grab your bag, stand up, and stand behind your chair for this. All right. No talking. You're just standing behind your chair. Make sure there's no trash on the floor. Look under your chair for trash. Pick it up. Middle table. Line up. Sit in your chair. Actually, push your chair over there. Your chair.